Greetings, folks. This is another part in my PrintNC Build adventure. Can't see in the screen, so I'm going to take my glasses off for a second. So, this is what we've got so far. The machine, as you can see behind me, is mechanically complete. This means that no wiring has been done, but all the mechanical features of the machine have been assembled and installed. I've had some issues getting this far. I have notes, and we're going to go through some of that now. I'm hoping that people watching this in the future before building or starting their build will be able to take advantage of the missteps and the traps that I fell into and save themselves some time and maybe a little money. Yeah, so we have things to discuss. First up, I'm going to get this out of the way. The fastener choice in the model, in the Fusion 360 model, is correct, okay? When you see a button head screw used in the model, that's right. If you see a cap head or a socket head cap screw used, that's correct. When you buy the hardware kit from the 3Design store, for whatever reason, the person that put it together decided, hey, we're just gonna ship them all socket head cap screws, which is wrong. I have opinions on that, but it really doesn't matter. I don't care why it was done. It shouldn't have been done. For people that live in metric countries, it's not that big of a deal. They can go out and they can get their button head screws where they need them and go from there. For us poor bastards living in America, getting our hands on metric hardware can be a steep hill to climb sometimes. Thank God for Amazon Prime at this point. So, let's see here. On the Y-axis BF12 mounting prep, I wanted to note that the BK12 blocks have 4 mounting holes, the BF12 blocks have 2. I made that change to the wiki so folks could spot that, or they'd be easier to identify. Onto the Y-axis mechanics assembly. And I have made changes to the wiki for most, if not all of these. When you're putting, or for the Y-axis mechanics assembly, you're going to be using or you're going to be putting together the ball screws. And one of the things it doesn't tell you is you're going to need some C-clip pliers to install the little C-clip that comes with the BF12 block. Yeah, the BF12 block. Another thing to note is the bearing that's inside that CF12 block or BF12 block. It can slide back and forth a little bit. It is a very, very precise fit, so you're just not going to bang on it and it's going to slide. It will move, but you have to be careful with it. I would recommend getting yourself a piece of PEX pipe, the correct diameter, and you only need a couple inches of it, and use that in conjunction with a rubber mallet to move that bearing in and out to position it where you need it to be. The ideal position for it is with the bearing all the way as close as it can get to the shoulder on the ball screw, and that leaves the groove for the C-clip exposed. That's not really mentioned in the manual, or really anywhere. I don't even know if the C-clips are modeled in the Fusion 360 model. I may have noted this in the wiki. The machined lip on the bearing block, or the nut that you put on the bearing block, it's got a machined lip to it, and that faces the bearing block. You'll also want to make sure that you get your Zerk fitting installed. onto the ball screw nut at this point. You can't use a straight Zerk fitting because it will prevent the ball screw mounting plate from mating completely to the back end of the ball screw nut. So you're going to have to go to a 45, maybe a 90. And nobody mentions that, which is kind of irritating. Okay. When you're putting the X and the Y rollers together, don't tighten them down. I say that, don't tighten them down yet. The reason I say that is because you may need to shim the ball screw nut, okay? And if everything's tightened, it's going to be just a real pain in the ass. I will go through tightening the ball screw nut to the face here in a second. I just kind of want to go through my errata. Looking through stuff here. Some of it doesn't matter, so I'm skipping that. If you want to see what changes I've made to the wiki, just look for changes by F15 Sim and you'll see it. You'll either laugh, enjoy the change, or revert it. It's up to you. I don't care at this point. One of the important things with the screws, in order to reach some of them, you're going to have to drill access holes. I've heard a litany of excuses as to why you shouldn't need to, but all of those involve purchasing tools you don't have or expecting patience nobody has. That's why you drill the access holes if you need them. And it'll be on this piece here. And I can't remember if that's the Y gantry or the X gantry at this point. It's been one of those days. Yeah, okay, so when you get to the portion of the instructions where you are mounting the, what is it called? The X-axis gantry. So yeah, that's what that stupid thing is. You need to use a really neat little tool that'll help you align it. It's called Tool 6A. But the ball screw has to be removed in order to actually use the thing. Okay? And nobody mentions that because it's in the way and it won't fit. The X-axis gantry HGR20 mount, which is back behind this thing. I recommend drilling and threading for the E-chain support at this point because you've got it available, it's easy access, and it should have been part of the model. I don't know why it's not. E-chain with a machine like this isn't a mod or optional. To put it bluntly, it's fucking required. And again, it doesn't matter what excuse is given that it's not in the model. It should have been in the model. It's the kind of thing that you need to know while you're building the machine. Otherwise, it's going to be a pain to drill holes for it and you'll end up taking things apart in order to do it. You shouldn't have to. Moving on to the X-axis gantry assembly. What do I have? C-clip plier note. You want to make sure that the Zerk on the top of the X roller is facing the back of the machine. That will give you access to it. Otherwise, you won't be able to reach it, and when it's time to grease them up, you'll be irritated. Again, when you're putting the set screw in the retainer nut, go ahead and install your Zerk fitting at that point. Pay attention to how the thing is oriented, or how your ball screw is oriented. And you're going to want that Zerk so it's facing out, or at least facing a direction that's easy to get at when everything's all assembled. Let's see here. What else am I running into? Nothing screaming or hollery yet. Mounting the Z faceplate. So I had some issues with the Z faceplate, primarily because I did not have an aluminum one at the time. The instructions for using a wooden one, they suck. It's kind of glossed over, and I didn't feel like dealing with it anymore because the fasteners that you need for a wood plate are longer than what you need for aluminum. And of course, you don't have any of those fasteners because they're not listed anywhere until you stumble across them at the step on the instant you need them. And that tends to be a theme. I would recommend that if you don't want the experience of machining your own Z-plate, you find one of the fine folks on the Discord that are offering those parts for sale and just buy them. The sanity you save will be your own. I also recommend that you buy the PNC Pro ball nut screw carriers. They're aluminum, they work great. I bought a set from a guy on Discord where I got my Z as well. Did an absolutely fantastic job. Okay, what else do we got here? More ranting about the wood that I'm just not gonna go. Yeah, we're gonna move past that. That horse has been beaten to death. Almost to the end of it. Z-axis motor mount. So you're going to want to install the ball screw into the BK block first. It makes the installation easier. And I also recommend getting the aluminum ball nut block. You'll appreciate your life more. Sanded. I'm either going to edit that out or I'll leave it in. We'll see. If you're running with the printed ball screw nut block, you may need to sand the inside bore to get it to fit properly. It may be too tight on the ball screw. So one of the reasons I recommend the aluminum one, it's easier to deal with. The Zerk fitting. Okay, the Zerk fitting on the Z-axis can be problematic. You can use an angled Zerk, but you're going to need to file down one face of it after you get it installed because the ball screw portion that the Zerk fitting is in is 8 millimeters thick. A straight Zerk is 7, but it's too short to clear the T-block. So you have two choices. You can use an angled Zerk, but it's 9 millimeters wide. So you're going to have to file you're going to have to file a millimeter off one of the flats after you get it installed and oriented correctly. Or you might be able to look at a straight long reach Zerk. It's 20 or 25 millimeters long, and it may fit within the 8 millimeters you have to work with on the Z-axis ball screws. But I don't know. I didn't buy one. I went ahead and filed down the 9 millimeter one that I had. This, of course, is not noted anywhere, or at least wasn't till at the time I was dealing with it. Z-axis mechanics assembly. Do I have anything? Nope, nothing of that. So the Z-axis mechanics stuff mentions in here, or does it mention? Give me a second. There's an assumption that you have a circlip that goes at the bottom of this threaded, or at this ball screw. The problem is that those circlips are included with the BF blocks. So unless you get a BF block for this, which is not typically something you do, you're not going to have that circlip. And I think an 8mm clip will work. The idea being is you want to put a 608 skate bearing here, okay? And that will prevent the weight of this thing from pulling it off the ball screw. That does not solve the problem of the carriages coming off, because the HDR carriages will come off of the hardened rail probably an inch before the ball screw falls off. If either happens, you're boned. You got to replace them. So during your build, I would either put a clamp here to prevent it from moving, from sliding. There's a gent on the Discord named Logan who has created some printed parts that snap into these bottom two holes that will prevent over travel of the HDR 20 carriages while you're building the machine. Do one of the two. Right now, because I don't have the spindle mounted, it's not heavy enough to pull that thing down on its own. If you look at it, I can sit here and put pressure to it and it moves, okay? The weight of the motor mount and the spindle is enough for that to happen. You can also try getting or spindling the wires together for your stepper motor when it's installed, because it effectively shorts the coils out and it makes it much harder to turn, and that could be a safety as well. It's entirely up to you. Just be aware of the consequences of what's going to happen if you don't do something and it slides too far. Let's see here. Yeah, and it looks like step 17. Yeah, before you mount the spindle, make sure the Z-axis carriages cannot slide off the rails. The weight of the spindle can backdrive the ball screw, which I just showed you. Put a 608 skate bearing or M8 nut on the end of the ball screw. An M8 nut won't fit. The end of the ball screw is not threaded. And secure it with a circlip. There is no circlips provided. But it's an 8mm circlip. So yeah. And that is the end of my notes for now. Now I'm going to change to the other camera, and now we're recording. Okay, we are going to talk about the ball screw and how it should feel when you've got it correctly installed, okay? If in a perfect world, and you've got this face of your roller square, and you've got a great printed part or the aluminum part here, okay? When everything is all tightened up, it should take almost no effort to move this ball screw and have this move, okay? The best way to find out what it feels, what perfect feels like, okay, is to hold on to the ball screw, and before you get any of this hardware installed or this or whatever, hold on to the ball screw nut, and with your other hand, rotate the ball screw, okay? So the only mechanical part that's moved, or that is involved here, is that nut and the rod, okay? That is the best case feel right there, okay? And when you have this set up and it's tight and it's 100% square, the amount of effort required to move this ball screw should only be a little bit more than what you felt when you just had this thing in your hand and there was nothing else involved, okay? The reason that it can get tight and it can get hard to move is if the shaft is passing through the roller here at an angle, okay? And it doesn't take much angle to start binding this ball screw up, okay? It doesn't sound like much of a problem at low speed, but at high speeds, it can actually jam and you'll skip steps and ruin a job or whatever you have going, okay? So make sure that when you're putting these together, you're going to want to do opposite holes, or opposite bolts. So you do this one, and then you do the one on the other side, and get those tight, and then check that again, okay? And start doing the other opposite pair, and then check it again, okay? You do it in pairs between checks because you want to make sure that both sides are tightened, okay? If you just tighten one side, it could kick the ball screw nut at a little angle and give you an invalid reading, as it were, okay? And the same holds true for the x-axis here. The y is not that big of a deal. It's not really a problem because the other end of the screw is not fixed. So it can move a little bit, and it's not a problem. You'll see here where I had to file off that Zerk a little bit to get it to clear. And then over here is where the Zerk are for that one. And the other Zerk is lower here for that one. And then on the ball screw back here, there's one accessible here. And then on the very bottom, if you look here, I have them pointed out so they're easy to reach. What else are we going to cover? I think that's just about it for the mechanical build. Someone had recommended to me that it would be a good idea to take this motor mount here and just put some holes in it. I don't recall the pattern. I'm sure somebody will speak up or ask in the Discord. The idea being is with holes already drilled and tapped here, if you need to mount some accessories like a mister tool or something, you've got the holes here. You don't have to disassemble half the thing to drop the thing in a drill press and get the holes drilled and get things done. This is another thing you're going to want to deal with. This is one of the mounts for the E-chain. You'll recall that I talked about making sure that you got this done and installed, okay? And if you look down the length, you'll see pairs of holes. That's for these. These are the E-chain supports. I haven't done this side because I didn't know about it when I was working with this piece of steel. So now I have to build some jigs and get that drilled with a hand drill. It doesn't make me happy. This stuff is not optional. It should have been talked about, okay? Anyway, this piece fits here and it supports the E-chain. Another one of those things is you can see this hole here. The bottom hole is fine, the top hole, not so much. It impinges on the motor mount. So just be aware of that. You'll probably have to modify the motor mount. This part has to be reprinted because I broke it, but you get the idea. In the back here, you see that's the bearing I was talking about that moves. It's very tight fit, but it does slide back and forth in the thickness of the block. And again, a piece of PEX that's the same outside diameter as the inside diameter of this hole, and a rubber mallet is a great thing for moving it around. And I think that's just about it. If you guys can think of anything else you want to know, put it in the comments, throw me an email, and we'll go from there. I have one more task to do that I forgot because I was rebuilding things after replacing my X and Y rollers. I need to tighten down this, and I need to tighten down the other rails. But that'll be the end of that. And then I've got other things I'm going to go back to work on, and the next task for this project is the electronics enclosure. I've got all the parts or components to build the enclosure based on Logan's design in the Discord. It's really cool. You guys should check it out. He has a great Fusion 360 model that shows all the bits and pieces and includes all the fasteners you need and everything else. And it's built out of 2020 extrusion, I think. Yeah. Anyway, really easy stuff to work with. And with that, I shall let you folks get back to your lives. Thank you very much for taking the time out of your day to watch this, and I will see you in the next video. Bye-bye.